So we're going to do a quick example doing redox stoichiometry. We're going to utilize our equation, the number of moles of electrons equals it over F, okay? And in this case, we're actually going to find how much mass is plated onto something using this equation. So to start with, let's read our question. Calculate the mass of zinc plated onto the cathode of an electrolytic cell by a current of 750 milliamps in 3.25 hours. So what's going on here is you have some cathode, okay? We don't care what it is. It's not actually zinc. It could be zinc. It could really be whatever metal you want. But all we know is your electrons in your wires going towards your cathode, as it always does. Remember, electrodes go from anode to cathode. Your electrodes are going here, electrons are going here, and they are creating zinc somehow, okay? And they're plating zinc onto that piece of metal. Now, we'll figure out what equation they're using in a little bit. First off, let's note some things we know. So we know our current is 750 milliamps, okay? I need to convert that to just be amps. How do I do that? I'm going to get rid of that milli by going to page 3 in your data booklet. And I'm going to replace the m for milli with 10 to the negative 3. So 750 times 10 to the negative 3 amps. You can plug that in your calculator, or you might be able to know how scientific notation works. So that will be 0.75 amps. Now, remember, this can also be 0.75 coulombs per second. Why do I mention that? Because our time has to be measured in seconds. So our time is 3.25 hours. Well, I need to convert this into seconds. So for every 1 hour, you have 3,600 seconds. Okay, my hours are going to cancel out, and you are going to get 11,700 seconds. Okay, we also know Faraday's constant. Faraday's constant is also found on page 3 in your data booklet, right here. So Faraday's constant equals 9.65 times 10 to the 4. And that's measured in coulombs per moles of electrons. Let's just make sure I got that right. 9.65 times 10 to the 4. Awesome. Now, why is this helpful? Realistically, with all the information we're given, at the moment, we can only use our equation it over F. Okay? But this is useful because the amount of zinc being plated is dependent on the amount of electrons going to this cathode. Now you may be asking why. If we go to our redox table, you're going to find that zinc, found right here, has a half reaction, a half reduction reaction, which does occur at the cathode. Remember, red cat. For every zinc 2 ions, it can add 2 electrons and form 1 mole of zinc solid. So we can use a mole ratio. If we know the number of moles of electrons, we can figure out the number of moles of zinc solid. So let's note this equation down. So for a single mole of zinc 2 ions, we can add 2 electrons, okay, and form 1 mole of zinc solid. Okay, so you have a mole ratio there. So if we can figure out the number of moles of electrons, we can figure out the number of moles of zinc solid. And if you have moles, you can find mass. So let's plug in our values into this equation. So time is 11,700 seconds. Current is 0.5 coulombs per second. And Faraday's constant is 9.65 times 10 to the 4 coulombs per moles of electrons. Now, the number of moles of electrons is a pretty ugly number that you're going to get when you plug this in your calculator. You are going to get 0.9093 blah, blah, blah moles of electrons. I'm going to store this in my calculator as A because when I use this value again, I need the absolute value, okay, not a estimated or rounded value. So now that I have the number of moles of electrons, I can use a mole ratio to figure out the number of moles of Zn solid, okay? I can do this by taking my moles of electrons and doing a need over know equation, okay? So the number of moles of Zn solid equals that number 0.9093 moles of electrons, and I'm going to use my mole ratio given by this equation. So the thing I need is zinc. So this will be 1 mole of Zn solid for every 2 moles of electrons. Notice that your moles of electrons nicely cancel out, and you are going to get a number of moles of zinc. So the number of moles of zinc solid would be our number 0.09 or 0.0909 blah 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 times 1 over half, which will give you 0.045 blah 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 moles of Zn solid. Now, again, we would store this in our calculator probably as B. And from there, we can use our equation, N equals m over m, okay? We're going to solve for little m, so mass equals molar mass times moles. Our molar mass is our zinc molar mass, which can be found in your data booklet, so let's go look for that. If we go on up here, we will find zinc right here, and zinc has a molar mass of 65.41. So 65.41 grams per mole of zinc solid multiplied by our number of moles. So 0.045 moles of zinc solid. And again, I would actually probably use the value B here. I don't use a rounded number. And you will get 2.97. I'm going to round it to 3 sig digs because we have 3 significant digits here, grams of zinc solid being plated. So this plated part would weigh 2.97 grams.